Alright, in this video we're going to look at another example of using chain rule to find some derivatives for multivariable functions. So we can see here that we've got f that is a function of x, y, and z, and then each of x, y, and z are functions of these other variables. So these variables are all Greek letters, which we'll actually use later for some things, so it's not a bad idea to learn them now. The one that looks like a P is actually a lowercase rho, and then the one that sort of looks like an empty set is phi or phi, depending on your preferred pronunciation, and then theta, which you're probably already familiar with. So I'm going to just go ahead and do my little chain rule diagram here. Got a lot of variables on this one, 2 levels, but a lot of variables at each level. And then I want to think about being able to write down the chain rule and find the derivatives for f with respect to each of the 3 terminal variables. All right, so if I want the partial derivative of f with respect to rho, say, then I just need to look at my tree diagram at these paths that take me from f to rho. I'm going to multiply down those branches and then add the contributions from each branch. So I'm going to go ahead and write down this chain rule. I'll have del f del x times del x del rho plus del f del y times del y del rho plus del f del z times del z del rho. All right, now at this point, if you can write down the chain rule correctly, now you need to just let the symbols tell you what to do. So I'm just going to find all these partial derivatives that the symbols tell me to find. So first of all, I have the partial derivative of f with respect to x. So I'm going to go up to my f as a function of x, y, z function and find that partial derivative. So I'll have 2xy e to the z. And then the partial derivative of x with respect to rho. So I'll just end up with sine of phi cosine theta. Then plus the partial derivative of f with respect to y. I'll have x squared e to the z times the partial derivative of y with respect to rho. So I'll have sine phi sine theta. And then I'm out of space on this row. I'll just squeeze this below. Then the partial derivative of f with respect to z. So that will be x squared y e to the z. And then times the partial derivative of z with respect to rho. So that will be cosine phi. All right, at this point, I have an answer, but my answer has 6 variables in it. Well, actually 5 variables in it because rho doesn't appear in that. So I have 5 variables in here. I would really prefer to not have 5 variables. We'd really prefer to just have our answer completely in terms of these terminal variables, rho, phi, and theta. So it's good form to go ahead and substitute for my x, y, and z. I'll end up with a long expression here, so I'm not going to talk through that. I'll just go ahead and write it down. Okay, so at this point, I've got del f del x all written in terms of rho, phi, and theta. If I'm only interested in just finding that and writing my answer in terms of rho, phi, and theta, I could leave it like that. If I'm going to use this for something else, maybe I want to simplify. There are some products that I could rewrite. I'm going to go ahead and just leave it at that point. Anything you do after that is essentially just algebra and sort of rearranging and rewriting. Okay, so then I have a couple of other partial derivatives I need to find. So I can find del f del phi. So I'm going to write down that chain rule, and then we'll just let the symbols tell us what to do and find the appropriate derivatives. So we'll have del f del x times del x del phi plus del f del y times del y del phi, and then plus del f del z times del z del phi. All right, when I do this partial derivative, I'm actually going to use some of my results from my previous step. My partial derivatives of f with respect to x, y, and z, notice that those turn up in both of my expressions here. So I've already found those, and in fact I've already converted those to be in terms of rho, phi, and theta. So I'm going to just replace those things I highlighted with the equivalent expressions in my sort of unsimplified form that I have in the previous answer. And then all I'm going to worry about is finding my new partial derivatives of x, y, and z with respect to these new variables. Okay, so you should be able to see here that the parts I've highlighted in my result are the same as in the previous step. And then the parts that are new here are my partial derivatives of my x function with respect to phi, and my partial derivative of my y function with respect to phi, and then the partial derivative of z with respect to phi. And again, if I'm really interested in cleaning this up or doing something else with this, maybe I want to do some simplifying, but if I just need to find the derivative and that's all I'm asked to do, I could just leave it in this sort of messy form. All right, for the last variable here, I just want to talk about one kind of relevant thing for the problem. So for the last variable, we might notice from our original expressions here that z is not actually a function of theta. So when I did my diagram at the beginning, I listed z as a function of theta, but z is not really a function of theta. There's no theta there. So I can go ahead and do that and set my diagram up that way. But since z is not really a function of theta, my partial derivative of z with respect to theta will be 0. So that contribution from that branch, when I think about differentiating with respect to theta, will zero out. So whatever my partial derivative of f with respect to z is, when I take that times 0 for del z del theta, that whole term will cancel out. So I'm really just going to have the contributions of f from x and from y for the partial derivatives with respect to theta. Okay, so I'll go ahead and write that one down. Okay, so hopefully you can see what I have here. I've got my del f del x, del f del y, and I could use del f del z if necessary from my previous step. I noted that del z del theta will be 0, so I don't actually need that whole last term there. And so I've highlighted my del f del x in my answer and my del f del y in the answer. I just used those from the previous step. And then what I have new here is my partial derivative of x with respect to theta and my partial derivative of y with respect to theta. And again, I could clean that up if necessary, but if all I want to do is write down my partial derivative, I can go ahead and leave it in this form. All right, that's about the most complicated example you're really going to need to do. So if you can get through ones like that, you should be good.